So continuing on page 227, part C on the try it. We're going to look at our variable terms here alphabetically. B would be the first letter that we have alphabetically. That's our only B term, so we can go ahead and bring that down. Negative 14 and 2/10 B. I forgot on the subtractions here, if you want to go ahead and add the opposites, you can do that. Our only other letter we have is D. We have two terms that have a D in it. And so if we look at these, one's positive and one's negative. So they're working against each other, they're fighting each other here. And so that means we're going to be subtracting them. Remember, when you add or subtract decimals, you need to have your decimal points lined up. So the 3 and 4/10, you could put a 0 there if you want, make it 3 and 40/100. So when we subtract that, we get 3 and 36/100. And we can see here we had more positives than we did negatives. So our answer would be positive, so that would be a plus. .36 D. And then we can look at our constants. We got two constants, two just plain numbers here. And are they working together or against each other? Together. So we're going to be adding those together. And then we'll see what we got. Again, we got to have our decimal points lined up. So the 1/18 and 7/10, you can put a 0 after that. And we get 216 and 5/100. Those were all negatives working together. So we got a bunch of negatives here. So that's, you could say plus negative 216 and 5/100, or you could just say minus 216 and 5/100. None of those are like terms, so we should have this simplified correctly. We look at part D. Again, if we want to start by looking at our numbers, or our variables rather. M is our first variable. Before we do that though, let's add the opposite. Only got one spot to do that, looks like. So M terms, we got a negative 1/6 M and a 7/10 M. I'm just going to go ahead and bring these down here so we can see what's happening. Again, when we add or subtract fractions, we have to have a common denominator. Worst case scenario is multiply your denominators together. So 6 times 10, 60 would work. We could actually get 30 to work here as well. If you don't see the 30, go with 60. That'll work also. So 6 times 5 to get 30, 10 times 3 to get 30. So that would be a negative 5/30 M and 21/30 M. These are working against each other because one's positive, one's negative. So we would be subtracting those. So if we do 21 minus 5, whoops, that should be a 30, not a 31. That would be 16. We have more positives, so that would be 16/30 M. And then those are both even, so we know we can reduce both of those by 2. So if we take half of each of those, 16/30 would reduce down to 8/15 M. That takes care of the M part. When we look at our other variable, we've got T's, and that's pretty straightforward there. We've got 5T plus 9T. Again, if it helps you to actually rewrite them next to each other, you can. If we just add those together, it's going to be 14T. I'm just going to bring that down, carry that down here on my work. And then we have two constants, two plane numbers. We've got a 3/8 here at the beginning, and we've got a 1/4. So we need to get a common denominator here again. Common denominator we could get would be 8. Okay, so that would be like 3/8 plus 2/8, and 3/8 plus 2/8, which would be 5/8. And again, we can double check, but none of these are like terms. So if we did this correctly, and we should be in good shape here. So the key concept on 228 is just kind of recapping what we talked about, looking for like terms and then combining those together. If we look at the do you know how number 4, Dylan says that 4b and negative 2b are not like terms because 4b is positive and negative 2b is negative. Is he correct?
No.
Okay, why not?
Because they have the same variable next to them, so that's what makes them like terms.
Good. Yeah, so we could say no. They have the same variable, which is just meaning the same letter, okay? So they are like terms. Okay, good. Number 5, Joel spent $28 for an internet data service and pays $14.50 per month. He spent $24.50 to join an online movie streaming site and pays $13.25 per month. Write an expression to represent Joel's total cost for both memberships after M months. So we look at this one. We can look at kind of two different parts here. The $28 he spent, that's kind of like that initial fee we talked about yesterday. And then $14.50 per month. I'm not sure what kind of internet provider he's with there. I'd like to find out who's charging him only that amount. But and then the $24.50 for the online movie, that was an initial fee again here. And then it's $13.25 per month. So if we look at this, like we talked about yesterday, if you want to, you can actually combine together your initial fees and your monthly fees before you work it out. The book was kind of doing two separate expressions and then combining them. If you want to just combine them first, that's fine. So if we look at this, we had a $28 one-time fee, and we had the $13.25. Oh, sorry. We had a $24.50 one-time fee, or initial fee. So we could actually go ahead and add those together. So we got $52.50, and then you can even see on the monthly bills here, they've got their monthly charges. So the $14.50 and the $13.25. So $27.75 would be the monthly amount that they're paying. So if we write an expression for this, we could just say we've got $52.50 plus $27.75 times M. If you had that switched around, a lot of times you'll see it switched around from this actually. $27.75 times M plus $52.50. A lot of times they put the variable terms first. You don't have to do that, just understand that's how they're going to put the answers a lot of times. If we look at number 6, we've got some n terms, some m terms, and some constants. They want us to add these together. So technically, if you wanted to write out first, we got 1/3 n plus 2/3 plus negative 1/6 n plus 1/6 m, just to show we're adding those together. Then it's just a matter of getting our like terms together. Alphabetically, m would come first here, so we only have one m term, so we could put that first, would just be 1/6 m. And then we look at our n terms. We don't have the same denominators. We got two n terms, different denominators, so we need to get a common denominator here. So 6 would work. So multiplying that first one, we could change that would be 2/6 n. 2/6 n plus negative 1/6 n. They're fighting it out. The positives are going to win by 1/6. And then we only have one constant here, which is 2/3. So this should be our answer for number 6. We go to workbook page 55. We're going to skip around here a little bit. We're going to start out with number 9. So number 9, they're telling us the width of a rectangle and the length of the rectangle. They're wanting us to find the perimeter. Okay, so we need to understand what it means, perimeter. So perimeter is the distance all the way around a figure. Just like a periscope lets you look around, a perimeter is the distance around something. So the width, we've got 3x minus 1.5. The length, we've got 1.25x plus 3. We know on a rectangle, how many lengths do we have? 2. How many widths do we have? 2. Good. So if you want to draw this out so you can see what's happening, and then to find the perimeter, what would we do with our sides? Add them together. Good. So we'll be adding these together, then just looking for any like terms that we have that we can combine together. So any of these subtractions, if you want to add the opposites on those, you can. And we're just going to get our like terms together here. So we got 4 different x terms that we can combine together. Starting with the easier ones, with the 3's, we know 3 plus 3 is 6. $1.25 and $1.25 is $2.50. So 6 plus 2.50 should be 8.50. So 8.50 or 8.5x. And then we look at our constants, just the plain numbers. Again, if we want to start with the easier stuff, 3 plus 3 is 6. And then negative 1 and 5/10, negative 1 and 5/10. Think about $1.50 and $1.50 would be $3. So that'd be negative 3. 6 plus negative 3 would be 3. So this would be our perimeter. Again, the 0 is optional. You could put 8 and 5/10 x plus 3 would be fine also. So page 229, I'd like you to do numbers 8 through 19.